In this presentation, we consider spherical mirrors. So a spherical mirror is basically a mirror that has the shape of a portion of a sphere. And what can happen with a spherical mirror is that we have a focus point. So when light comes in parallel, the light can actually bend or reflect off of the surfaces in such a way that it goes to a particular point or seems to diverge from a particular point. So we're not going to spend a lot of time on this. I just wanted to sort of show that you can have different types of images formed by mirrors other than plane mirrors. So a concave mirror is a spherical mirror that the light reflects off of the inner surface, and a convex mirror is one that the light reflects on the outer surface, and we'll see some pictures of those. So here's a concave mirror, and rays of light come in parallel to that mirror, and here is the reflective side of the surface. So you can see it's spherical in the sense that, if you continued this out, it would, it would come around, and you could imagine it making a complete sphere. And what we notice is that when the rays of light reflect off of the surface, the law of reflection is still valid, but because of the way this is curved and the way that the rays of light are coming in, they all seem to reflect to a particular point when they come in parallel. And that's called the focal point. So just to kind of show you that different types of images can be formed based on different shapes of mirrors, the type of image for concave mirrors depends on where the object is located. So in this particular picture, I have an object, it's a candle, and it's located pretty far away from the focal point over here. And then there's also something called the center of curvature, which is basically twice the focal length. So the distance from the mirror to the point where the rays of light converge is the focal point, and then another, if you take that distance and then you add it again, that's where your center of curvature is. So this is just going to keep repeating itself, this picture. Actually, I think I have another picture here that's also going to repeat itself, but that's okay. Essentially, what we notice is that when you look at the rays of light coming in, where they meet over here is where the image is formed. This is a real image because the image is formed on the same side of the mirror as the object is located, and the rays of light that reflect off of that mirrored surface actually come together and they meet, and that's where the image is formed. And this is just another picture, and it just sort of shows you that the eye can see the rays of light actually coming together at different locations, and it shows us more rays of light reflecting off that surface and all coming together. So this is a real image. In this particular case, the image is inverted because if you look at it, it's upside down compared to the object, and it's smaller. If you take the object and you place it between the center of curvature and the focal point on a concave mirror, you get an image that's formed, and that image is still inverted and it's real, but it's larger. So the rays of light actually come together and they form an inverted image. And so here's an actual spherical mirror that's concave, and it's here is our actual candle right here, and then here is the image. It's kind of hard to see this because it should be kind of floating out in front of the mirror, and it's just difficult to see in this particular picture. If you take the object for a concave mirror and you place it within the focal length of the mirror, then what happens is that the rays of light don't actually converge, they diverge. So the rays of light that are coming off of here they're going one way and then the other way. You have to follow those rays of light back, similar to what we had to do with the plane mirror, and we see where the location of the image is, and the image is formed behind the mirror and it's larger. So this would be a virtual image because the image is formed behind the mirror. And here's a picture of that here as well. So here's my actual candle, and then here is the image. It's upright and it's larger. Convex mirrors, on the other hand, are sometimes called diverging mirrors because when rays of light come in parallel, they tend to reflect off according to the law of reflection, and they diverge. But if I were to follow those rays of light back, all of those individual rays, they would seem like they were emanating from some point behind the mirror, and that point is called the focal point of a convex mirror. Convex mirrors will always form virtual images, and we'll see that in this particular picture. So here's one that's not animated, which actually is kind of nice. So with a convex mirror, when you place the object, so here's my object right here in front of the mirror, rays of light come in. So this particular ray of light comes in, it reflects off of the surface. I have another ray of light that comes in, reflects off the surface, and then there's another one. And these rays of light, there's a pink one, a yellow one, and a blue one, they all diverge from one another when they reflect off the surface. So if the eye is over here looking into the mirror, the eye believes that these rays of light come from some point, and if I follow them back and we look at the dotted lines, it appears as if those rays of light come from this particular point right here, which is what we were looking at on the object, was the top of the object. So this is the top of the image that's formed. So again, remember the eye believes that light travels in a straight line. It always follows where those rays of light either come together or seem to emanate from. So this is a virtual image, and it is upright and it's smaller. So one of the things that you may have noticed is that all virtual images, when we're talking about mirrors, are always upright. And all real images, which are formed on the same side of the mirror as the object, are always inverted. An example of this, and I don't know how many people have seen the original Jurassic Park movie anymore, but there's a scene in there, and you can even see this on your cars, where it says, objects in the mirror are closer than they appear. And so your side mirrors on your car are actually convex. They look flat, but they actually have some curve to them, and it allows us to see a wider spread of from our side mirrors, but the images are also smaller, so they're actually closer than they appear to be because they're smaller in our view, right? And so we think of them as being farther away. It's also an example of mirrors in convenience stores. I don't know how much they use these anymore, but because we have cameras now, but um, back in the day, a long time ago, you would often see these types of mirrors in the corners of convenience stores because you can see a wide range of the store itself, and they could kind of keep an eye on people.